My name's James Doig. I've been working at the National Archives of Australia for 20 years. Unlike a lot of the people who were talking yesterday, I'm not a software engineer, I'm not a computer scientist. I'm actually an archivist, but for a lot of the 20 years I've worked at the National Archives, I have worked in digital preservation and on a number of projects involving our approach to digital preservation, and I've developed some digital capability along the way. In fact, I've got a PhD in medieval English history, and I do find in talking to people who are involved in digital preservation that a lot of us do come from all sorts of different and wild backgrounds, and I guess I'm one of those people. In some ways, I feel like a bit of a fraud, because when I look at where many European archives are with database transfer and preservation, it seems that in Australia, we're quite a long way behind, and we're still playing catch up a bit. In the time I've got today, this is what I want to cover: a bit of history of digital records at the National Archives of Australia, of digital preservation here, how we've dealt with data contained in databases up to this point, and some recent work to improve our practices and some of the challenges associated with that. Probably like a lot of archives and national institutions in particular, NAA began receiving transfers of digital records quite early on, at least since 1970. And of course, these came to us mainly on magnetic tape, and they were stored in an offline storage environment. And they were retrieved when someone requested them and accessed via computers in our reading rooms. And by the early 1990s, it became apparent that treating digital records like paper records wasn't sustainable, and the continued accessibility of the tapes and other types of stored media was under threat. Not, I should say, by the physical degradation of the tapes, but by the obsolescence of both the hardware and of the formats used to encode the data on the tapes. In other words, this was a classic digital preservation problem. So for a time in the mid to late 90s, we adopted what's called a distributed custody model, whereby we didn't accept transfers of digital records. So digital records remained with agencies which were responsible for maintaining their archival value data under a management regime worked out with the National Archives. And this was the time when the National Archives was focused on developing some of those important early standards for information management and record keeping metadata. We changed tack in 2001 when we commenced a digital preservation program. And this program had a number of goals, including developing a digital archive, a digital preservation software platform, and to start taking in transfers of digital records again. In that time in the early 2000s, we also started to carry out some early data recovery projects on the magnetic tapes and the discs that we had received since the 1970s. And this was interesting because some of the tapes contain proprietary database formats. For example, an early 1980s public inquiry into a union engaged in criminal activities was the first inquiry in Australia to use a computer information management system to manage and provide access to a wide range of investigative material. The system allowed names and crimes to be cross-checked and referenced, and the disk images and the bit files we recovered could provide important insights into early computerized records and information management practices. But while we recovered the bits and we can access at least some of the content, and here is some of that content, we need some way to interpret it. So we've been involved in the Emulation as a Service infrastructure program of work, and it's possible that emulation might provide a means to allow more meaningful access to this data. But one of the problems we have is that there is very little available information about the particular information management system. There's almost no information about the computer system recorded in transfer or series documentation. And in the early 1980s, nobody thought that this basic type of information would be important. Anyway, to get back to the digital preservation program, from 2000 we began accepting transfers of digital records again. And by 2007 we had an operational digital archive and we were ingesting these records. To fast forward a bit, in 2020 we acquired Preservica to replace the bespoke digital preservation software platform, and we're in the process now of preparing for a data migration into that new system. So what have we been doing about database transfers from government agencies since 2000, when we started to accept digital records transfers again? Well, one thing is that we haven't received many transfers from purely database systems. And I should make the point at this stage that by database systems, I'm not talking about electronic document and records management systems, document management systems, case management systems, those types of systems which are still underpinned by relational databases. We just don't manage those types of systems as databases. Rather, from those types of systems, we transfer and ingest the individual records or their aggregations. For example, a case file, a trim file, or a document, or whatever it might be. That said, I would argue more broadly that we haven't received the number and quantity of digital records transfers that we would expect to receive. For example, regular transfers of records from EDRMSs, document management systems, case management systems, and so on. The vast majority of transfers that we've received have been from short-term agencies, like the public inquiries I mentioned earlier, and agencies that have closed because their functions have been abolished or moved to another agency. I'd say at least part of the reason for this is that there is a disconnect between the analysis of agency systems and the concurrent development of disposal schedules on the one hand, and the transfer of government information to the archive on the other. Looking at some of the European examples, the technical requirements for transfer and the scheduling of transfers is happening up front. And that point of contact with agencies, when agency systems are being identified, disposal schedules are being developed. On the other hand, in the Commonwealth Government of Australia, we leave it to the agencies to decide when they'll transfer, pretty much. And it's only at the point of transfer that we decide the technical form the transfer will take. So what this has meant in practice is that when the time comes for transfer, we fall back on easy options. So let's have a look at a few examples. I think it's true to say that we learn the most as archivists from problematic and poor practice. And I think perhaps this first example is sort of one of those examples of potentially poor practice. It's the data from the 2007 federal election results. And it's also a good one to show because the data itself is public, it's in the public domain, and it's available from the Australian Data Archive, so I'm not going to get into trouble for showing a few snips or screenshots of it. So now, the disposal schedule, one in Australia we call a Records Authority, was approved in 2004, and we received this transfer in 2008. And this is the description of the disposal class for the election results. So see the third dot point here, and I hope you can see the slide okay. So it says that third dot point, official results in statistical tables. And the next few slides show what we actually received from the Australian Electoral Commission. Folders containing zip files, containing CSV files of the actual results, of which this is an example. So what we received was within the letter of the disposal class description, statistical tables, essentially the raw data. But if we consider the system or systems used by the Australian Electoral Office to input, process and analyse the election data, then there's a lot of potentially important functionality that has been lost. But what's worth, however, is the quality of archival description. And as I've said, I've chosen a particularly bad example to make my point. This is a screenshot of the series registration for this data set on our public catalogue. So as you can see, it's a pretty minimalist series registration. In fact, you probably couldn't get much more minimalist than this. There's almost no information at all. But I'm showing it because it raises the question of what metadata or information do we want to capture about the data set to make it usable and understandable in years to come, to help us to understand the context in which the data was created and used. Not only important archival information about the function and purpose of the data set, but technical information about the business system or systems, its development history, how it worked, what statistical analysis software was used, and so on. Now, the actual data set's a fairly large set of CSV files contained in the file structure, like I showed you before. And all of those CSV files and zip files are in a single item, this one, also on our catalogue, called Federal Election Results 2007 text files. And again, there's very little contextual or other information here about those CSV files. In fact, the title probably wrongly says they are text files. And have we got the level right here? I mean, dumping the entire data set under a single item. What this means is that when a researcher requests it, they'll receive everything and they'll have to make sense of it themselves. Certainly more time should have been taken to consider how to control and describe the data set, both series and item level control, and get a lot more information out of the transferring agency. So a number of problems are clearly evident. Archival description provides the context to understand records creation and management when the record was in active use in the agency. In this case, at the most fundamental level, there's no information about the original system that managed the data set. Another omission, probably the worst omission, is the lack of technical information about the data that was exported from the data set or the database. And this will undoubtedly become a big problem going forwards. And finally, we have the raw data itself. In this case, we have the data exported out of the database in CSV format. In itself, that's not a bad thing. It's an open format, it's well documented, you can sort it, you can analyse the data, import it into other data crunching software and so on. But in other ways, it's not ideal. For example, there's nothing explaining the relationships between all of the many CSV files and the transfer. If those relationships were somehow maintained, it might make the data more usable in more sophisticated ways. And also the raw data itself does not preserve any of the functionality of the agency system used to import and process the data. But here's another example from our collection. It's interesting because what was transferred was quite different from what was transferred in the election results 2007 series. This was a property valuation database used by the Australian Valuation Office. And that system was called Voice, the Valuation Office Information System. It was transferred to us in 2014 when the agency was abolished and its functions moved to the Australian Taxation Office. So what did we receive in the transfer? Well, first, we received the data in native SQL formats. The database management system was Microsoft SQL Server, and the formats are in the SQL Server data format .mdf and the log file .ldf. Just as a matter of interest, these files have been ingested into Preservica and are managed there within, Preservica, though Preservica, as you can see there, can't identify those SQL data formats. As well as the native SQL data files, the transfer included an export of the database tables in XML. And this screenshot shows the various XML and files. And here's the one of those XML files opened up. And of course, the advantage with XML, of course, is that it's both machine and human readable. However, it's not necessarily easy to import them back into a database management system if you wanted to recreate the database. Importantly, a full suite of technical documentation was transferred, including the data dictionary, And as you can see from this screenshot, the data dictionary defines and explains the data tables and the data elements. And it's also worth saying here that we also received screenshots of the database user interface showing how it was actually used by the agency, and that's quite important too. But once again, the transfer documentation was quite poor, which means this series description on our catalogue, again, isn't great, but at least there's some information there in the series notes, the number of tables, number of database records, the purpose of the database, and so on. And finally, here are some of the item registrations for the series. Basically, 3 high-level items: controlling the files transferred and the documentation we received. So here's the problems we identified with transfers of data contained in databases. And the biggest problem, I think, is that transfer decisions about what to transfer, how to transfer, and when to transfer are not made when the disposal schedule is developed. And this creates enormous downstream problems for the archive. And in order to solve these problems, we commenced a database preservation project, which ran from December 2020 to July this year. It drew on the expertise of a reference group that was drawn from different business areas across the National Archives. I'll just go through some of the deliverables of the project. We did have a close look at the database preservation toolkit, which we found was very easy to deploy and use. And we thought a good approach would actually be to use it to create a SIARD file from an existing transfer, which we would then ingest into Preservica. So we used the AVO database I mentioned earlier, for which we had the native SQL. Of course, the database preservation toolkit must connect to a live version of the database. So we imported the native SQL files into an instance of SQL Server and used the database preservation toolkit to create the SIARD file. And that process worked fine. Though, of course, this was a relatively small business system. Now, about this approach, we do believe that creating SIARD files at the archive will probably be the norm, at least in the medium term, because we foresee agencies being reluctant to download and use the database preservation toolkit for IT security reasons. And we had a very similar issue for a SIP creation tool created years ago for agencies to create their submission information packages. They just wouldn't use it, or most of them wouldn't. And we had to just do a lot of the work in-house to create the SIPs. But look, I might be wrong about this agency reluctance, but at least we have demonstrated it's perfectly feasible to receive native SQL files and create the SIARD file in-house.
Just to interrupt for a second, James, yes. You've got exhausted your 20 minutes and you should be finishing sometime. Thanks. But you're fascinating, okay. So I forgot to stop very quickly.
Yeah, what I'll do, I'll just spend 30 seconds or a minute going through some of these other products. I've almost finished. So the other products that the project developed essentially are staff guidance, for example, for use by archive staff when negotiating transfers and making decisions about what needs to be transferred. So we developed this checklist of questions. Another product was guidance for determining options for transfer. For example, sometimes perfectly adequate to seek an export of raw data, an export of reports from a system, rather than to try to preserve database functionality. We also developed process maps to give an overview for staff and agencies of the process, and a document describing metadata we require in addition to the standard metadata requirements of the series system. So what we've got is a more flexible and hopefully a more sophisticated approach to database transfer. We still need to do those things a government archive typically does: interpret disposal class descriptions, analyse the systems in which records are held and so on. And look, a transfer could comprise a combination of all those things listed here on the slide. There's no one-size-fits-all approach. Future work, we've got to continue to develop our internal knowledge and capability. We know that's a big issue. We've got a couple of important database transfers possibly coming up from different agencies. I know there's one of a register that's using Microsoft Dynamics, one Lotus Notes, and we do still need to work with agencies to embed transfer decisions in the records authority creation process. And that's all I've got for you. So thanks very much.
Yes, I will. Thank you very much. I hope you can all hear me clearly, and you can already see my presentation. Is this right?
Yeah.
Yeah, very good. Thank you. I myself, I'm working at the Bavarian State Archives, and here I'm for about 5 years now. I'm responsible for the transfer of digital data to our digital archive and for developing interfaces for doing this. As Kai said, I'm not a software developer, so I'm looking at this, at the needs for interfaces, of course, out of an archival perspective. So, having said this, I will present you a one-fits-all approach, as James called it, which we developed in the last 2 years, and I'm very glad to be here. Kai, thank you for your invitation and to present to you our new tool for database archiving. And of course, our motivation to develop it. As each of you well know, database specialized systems are in use by state agencies in many areas. More than 3,000 individual systems are, for example, used just in Bavaria. Naturally, not all the data from these systems is worth to be archived. Nevertheless, all official and scientific departments are using important and powerful databases today and data systems, for example, providing internal security, social and financial administration, as well as scientific, environmental and agricultural systems. These data systems are providing and keeping valuable information in very high volumes, thus backing up needs of the administration or other concerned parties, but also providing a most valuable source for several possibilities of scientific reuse and evaluation of this data in the future. First surveys suggested that this use is to be expected by 15 to 20% of the official administration specialized systems. And that means we need interfaces fit for archiving data for about 400 to 600 individual software systems, only for government agencies in Bavaria. In general, and not directly connected with use and contents, data systems provide detailed information and thematically organized databases. The individual data might come from measurements, could be recorded by official administration, or might be transferred automatically from standard forms. This data might then also be changed or overwritten in the following use. In addition to these partly flexible and volatile data, also defined data and documents like text documents, photographs, audio and video data and the like might be secured in these data fields as binary large objects. Depending on its intended use, information on singular issues, for example, an investigation checkup or other processes on people, places, animals, or cases in general, can be featured from the different and sometimes numerous charts. This information can then be shown structurally, worked on, and be exploited, thus even leading to newly defined and constructed documents, for example, official notices and accounts. And usually, as you well know for yourselves, there are no adequate archival interfaces managing a structured output of data properly interpreted and documented in archival formats for the long-term archiving of these informations. And our approach is not the emulation of the systems. We don't believe in emulation, as I stated. We follow a strictly way of format migration and extracting of relevant data. This is the systems we think what is needed is a standard solution for the great number of currently used systems, which is not to be seen somewhere because, which is also the case because archives have not communicated the specific need in this area properly. Development and preservation of singular solutions for each of the about 600 individual special systems provided by our institutions producing archival information does not make any sense in an economic as well as a professional sense. A certain aspect of standardization in this field does not only provide the basis of automatization for important procedures, but secures meaningful connection of information from different providings as well as proper secondary use. The extraction of these informations and data from the provenance systems is followed by the Bavarian State Archives in principle, because it is believed that only this approach will allow interpretation of the data in a long-term perspective, as I stated above. In order to close the gap and to develop a one-fits-all solution, it has been decided by the Bavarian State Archives last year to develop a generalized XML client for the main administrative procedures, including, for example, personal, object, or creature-bound data. This tool will be installed in a test environment in the next weeks and should be set in use by the end of the year. The basis here is an archival client system that has been developed in 2017 in order to transfer data from the Bavarian SAP human resource system Viva in a fully automatized way. Since then, by comfortably using this client system just by pressing a button, it is possible to validate, structure, ingest, save archival description information automatically in the archival information system and confirm the receipt of the data on 10,000s of Bavarian state employees. This interface could only be realized by a long and detailed technical development and effective cooperation between the archives and the data delivering institutions which provide data delivery from the employee departments in XML format and thus an automatized processing. In order to use this data client flexibly for other data source systems as well, and also to enable a structured archiving of connected binary large data objects, the current system was now being developed in the following way. A so-called mapping tool is based as a central component, configuring the treatment of the release data from different origins and depositing this for following archival transfers. This means that the mapping tool secures for the archiving of several individual data origins certain rules of development, which are to be implemented automatically. Here in the mapping tool, it can be defined how to validate data, how this and other single data are to be designated, whether an appraisal is required, what kind of metadata might be presented in a GUI for appraisal, and who the archival information packages are to, and how the archival information packages are to be structured. Following this structure base, XML data then can be divided and possibly included with defined documents like pictures, maps, and text issues, which can be allocated to the different XML sections. The ongoing development of the Beaver client also made possible a structural processing of perfunctory as well as defined documents. That is, data sets from data pools, text documents, plans, photographs, and so on. In addition, it is defined in the mapping tool what kind of attribute values are to be mapped in the digital archival as in the digital archive as archival description, accessibility information in our database, our special archive information system. So according to the origin of the data, the accessibility level and the choice of information provided for later use can be adapted individually. After this configuration process and the mapping tool, several singular tools that may be maintained individually are proceeding the following workflow automatically. The slide is in German only, but I hope you can follow anyway. First, it is checked continually by share auditors whether incoming data packages are expected due to a configured register and whether these data packages conform to the mapping tool data name convention. If this is the case, the incoming data is validated on the configured XSD schematic data and its submission information package ingested to the archival data storage. In case this is already provided for the tape of incoming data, these can be valued by a GUI, accessible over browser, and so showing up metadata secured in the mapping tool for appraisal. Following the ex-ante given rules, the primary data XML will be divided and the documents, photographs, plans, etc. referenced via UUID are structured into archival information packages, which will then be ingested into our digital archive. Defined attribute descriptions from the primary data XML will then be contributed to our archival information system, and information data objects will thus be described. In this way, processed data is accessible for different reuse scenarios, for complete analysis using the major XML data, as well as for single research. Following the origin system or the research project individually, it is also possible to adapt the structural granularity of the archival information packages. This allows the secure use of long-tail data for single and small projects, as well as big data systems. For example, student data from the universities, science data from agricultural livestock companies, regional and environmental control databases, or specialist databases from construction administration. After successfully having processed the data, the institution having offered the data is given a receipt produced automatically and documenting offering, archival ingestion, and possible deletion of this data in case there was an appraisal implemented. Hash values are controlled during all copying processes, and every single working step can securely be resetted. All archival working steps are recorded professionally, starting with initially receiving data, following up assessment decisions and deleting, as well as the division of the submission packages into single archival information packages, then secured, recorded, and added on receipt in the archival records and the archival information system. In addition, a TXT file with timestamp, authorized issuer sign, concerned data, and conducted workflow is conducted and saved as singular archival information package in the digital archive. This guarantees, as we hope, the archival conformability on a high level and secures a widely automated processing on a sufficiently flexible basis. Especially, the securing of data provenance is of great importance to us, as it safely provides possible legal relevance as well as scientific secondary multiple use of the data. However, neither this special workflow for the XML client nor individual structural determinations for the offered data, or indeed XML data, are to be expected as a given standard. But the automized workflow and the given expected standard of the data transfer system may produce realistic advantages that are positively effective, as well for us as archivists, as well as the establishments disposing the individual data, and indeed anyone later interested to reuse the data. In conclusion, all data producers can thus be informed already when generating information data or when planning to generate special data systems or updating a system on which interface they are later to implement. We are able to define what kind of data structures and versions and indeed metadata needs to be accomplished in the end of any process in order to keep them accessible, to be interpreted, and to use them further on for a variety of purposes. This then helps to provide definite information for practical data and information management and to evaluate expected efforts. But most important, in this way, data will be archived in a structured way, following their origin development and in an appropriate long-term archiving format, facilitating further processing and assessment. Although we are not able to archive the database itself, but only the extracted data and documentation information about the database. Naturally, we are already considering the best ways to develop this tool further on. Possible other automatization steps could be the enhancement with standardized metadata from external resources, or with the relevant standards defined by the respectively science community. We are also thinking about an automized definition of significant characteristics for data coming from specific origin systems, or assigning data to preservation units following different formats. Until then, our XML client offers an effective procedure in the use of archival interfaces for any type of proceedings in administration as well as science. Information from these proceedings, from these data systems, worthy for archival storage can thus be structured, documented adequately, and kept in a comprehensible way. This allows the comprehensible processing of great data volumes, accessible with the push of a button and keeping them accessible in a format offering long-term archiving as well as process continuing in different reuse scenarios. Thank you very much.
can see on the slides, and we're happy to hear you.
Yes, I've been working in this municipal archive since 2007. So in that case, we're fortunate to have a continuity working on the matter, because this is an area of development, and we're creating new things along the way in a rather small community. So myself, I'm educated in telecommunication, so I've been working all from development of systems and integration of systems, and now I'm on the other side. I'm buying or receiving software systems and using them, and also in the archiving over them. Okay, I think I will just start. My title is somewhat changed from what the agenda says, but the main thing is ingest, preservation, and visualization. And we are using SIARD as a method in preserving those systems. IKMR, it's a municipal archive in the west coast of Norway. And after the latest reorganization of counties, there are now 11 counties in Norway. We have had a recent election of and change of political rulers, so it's talk about like the northern blue county to be divided again. That was recently put together. So it's a huge discussion about organization, etc. But for us as an archive, we have seen the benefits of somewhat larger units, because the municipals are easier to manage. And this is our county of Møre og Romsdal. As you can see, the west coast, it's a long tradition of fishing community, and it's lots of fjords and mountains, and the city of Ålesund, where I am living, is in the center of our county. And as you can see, we have the Jugend style from the large fire we had in 1904, and the Emperor of Germany helping with sending supplies and rebuilt the city. And it's ended in the style, as you can see. And if you're nearby or visiting Ålesund, just make contact, and we can take out and perhaps eat bacalao. It's the best raw material in fish nearby. We have 28 employees, including 2 ET archivists. My colleague is sitting in the same room as me, so we have close work on the archiving. Our owners are the 27 municipalities and the county municipality of Møre og Romsdal. If we look in the other direction, we are 18 municipal archives who have founded a digital resource center. And in total, we cover 81% of the municipalities and county municipalities. One of the core services is a digital repository based on the OAs to its members, and it's the SIARD solution we are currently using, provided by the ES solutions in Sweden. We have a community for ET archivists, as we are distributed all around Norway, and each one of us have 1 or 2, or some of them have even more than that, but it's very distributed, so it's very important to have a good community. And also we have for years a very good cooperation with the National Archives of Norway. Now, about the preservation methods. As I started in 2007, I had a colleague work that left the job here, and I started after him. And even 2 years earlier, in 2005, we have started with table extractions, and I will explain that later how it works. And we kind of had that in progress until 2011, and later, starting from 2015, we have started receiving NUARC 5 extractions. We'll also explain what exactly that is later. And this is one of the 2 main methods we're using today. And finally, our archive have started receiving SIARD extraction from 2014, and this is the second main method we are using today. Now, about table extractions, in the old way, each table was connected to and extracted into its own table XML. And the metadata for the database was structured into its own ADDML XML. It's a Nordic Nordic national archives have joined together to create this metadata standard. And from 2005 to 2011, we have preserved a total of 50 database systems, and it's finalized into those early archival packages. At start, we visited the municipal and talked to the IT staff and connected with our tool. At the time, it was pervasive. It's an expert tool, but very, very hard to use and very hard to reuse later. But it's an expert tool and very good at migrating data and transforming data from the left side to the right side. So we visited a community and we pointed out, okay, this is 3 tables. It's the main topic table, and it's the subfolder of what we call I don't know the English name of it, but the journal post. You know, the main case and all the different types. Or the third table could be perhaps information of documents or main documents and secondary documents, and also could be meeting for the municipals. And after 6 months later, we found, okay, there's 5 more tables that need to be preserved. Okay, we added 5 more tables, going to 8, and this gradually ended up, we did at some point full ingest of the database, a full copy from the original system and back to our office and in our archival work area too. So we no longer had to sit out working at the site, but make a full copy and can do it in time at our local area. And it's typically, it's an example of an XML file of the metadata. The table itself is just, it's the columns and values, etc. of the data. But this is basically the database structure described like in tables, columns, column types, and we can see nonal and unique is the very on spot on the details of the database. In addition, ADDML had some descriptive metadata of the system and also of the agents involved. Now about NUARC 5 extractions, it's the current Norwegian archive standard. We have had NUARC 3, NUARC 4, and this is the latest. And it's for record keeping system used in public administration. Now the archivists in the municipal, they know this system, use it daily, and they're experts on using it. So and also when we get the extraction, they are well ordered and should be compliant to standard, and we validate it accordingly. We either approve it or reject it, and we will not whatsoever go inside it and edit it, because there are very strong authentication and checksums, etc. So we don't want to ruin that relation. From 2015 and up to today, we have ingested 50 such systems. And we have a long work list of finalizing such systems. So me and my colleague have more than enough work to do on it. And as of the well order, it's like you see at start off at the top. You have the archive, you have the sub-archive possibly, and parts of the archive classification and classes, and they have the down to the records and the documents further below. The SIARD extraction we have used in a community from 2011. Introducing with the SIARD suite from the Swiss National Archives. Ourselves, we did our first extraction and ingest of this in 2014 using SIARD suite 178, I believe, and it was a child care system. And if you look at the child care system versus the public record main system, then you have the expertise of this is distributed in that section of the municipal. So already it's been quite a distance from the origin. From 2014 up to date, we have ingested 100 SIARD extractions, and we have a long list of working on it. There are some duplicates in this number, but it's a lot of systems. A few of them have been extracted using SIARD Suite 1 and later 2.1, so in SIARD 2.1. A few of them have been using Database Visualization Toolkit 2.0 and the new SIARD 2.1 platforms, as Luis Faria demonstrated yesterday. But most of them are using Spectacor Full Convert as Damir showed yesterday as well, creating SIARD 2.1 extractions. And a SIARD extraction using Full Convert, and it's almost the same of the two other tools. We have the top level metadata section as you see here, and schemas, tables, columns, and an example of a lob folder metadata. Up, right, and also this is the example of the lob at an internal lob folder, where you can see we have the schema table and a lob 9. Lob 9 means it's the 9th column where this lob element exists. And Full Convert also implements an additional subfolder inside the SIARD folder, which is named seg0 and counting up, consisting of up to 1,000 files in each segment here. The production line we are using, and now I switch to a CODRS slide I used earlier. We have the extraction into zip, the archival depot. We are adding the description using the tool document, ending up with an archival package, IEP, stored down in the repository, as we are using SIARD for this. And to the right side, we have the access and the possibly dissemination package DIP. And down left side, we can see SIARD. We are using Spectacor Full Convert, SIARD Suite, and Database Visualization Toolkit. The process from getting the extraction in delivered to the archive. We use a free tool from the Archive, which is provided for free from the Norwegian National Archives. And it puts the SIARD package, also any other extraction we have, like NORC5 or other. The dia-zip, it's a .tar file, and the metadata in the corresponding info.xml on the side. And the coming Archive 5 version 2.50 can validate SIARD 2.1 using the dbptk developer 299 validate section. And also it can make a pronoun file list. It uses Siegfried. I believe it's similar to the Droid pronoun analysis program. Norway is, as you can see, not using the eArc-zip IAP DIP package formats. Perhaps in the future we will join forces and use the same package, but as is today, we have the dia-zip package system. somewhat similar, but it's its own thing. And this is how the Archive 5 looks, validating a SIARD package. When we talk about the SIARD ingest and refining to archives, we are, okay, typo here. The SIARD extraction with an X is imported into our tool DCOM, which is developed by the vendor DocuMaster for the CodeRes production line. We have a template server, a DCOM server, which currently holds over 60 system descriptions. And this is used to handle the unordered extraction. In the municipal area of Norway, we have some main vendors and some main systems that are reused all over Norway. So if one of my colleagues make a full description of one of those childcare systems, and maybe he use 4 weeks up to 6 weeks describing, it can be 450 tables, and you need to check every table, column, data, and describe and look at the foreign keys, how it maps to each other. And by using such a template, if I have the same system, I reuse his template, and I can possibly use 1 week instead of 4 to 6 weeks. So if we like have 100 systems and we save 3 to 5 weeks, it's like saving of 300 to 500 weeks of work. The simple math template is good for our efficiency. The lobs in the production format is also transformed from production to archival formats. As we could see in the previous slide, a binary file in the database is extracted into a bin file. As the tool just see raw data and you don't know what it really was. And the pronoun analysis we use in DCOM, in fact, it's a MIME analysis for now. The MIME analysis will tell if it is Word document or it's an RF document or other format we support to transform, and we will change it from to be .bin file into a .doc or .pdf-a, and store it in the end resulting SIARD file as the archival format instead of the document in the Word format. The access to preserved SIARD extraction systems for visualization are under evaluation as we speak, and we are testing out the database visualization toolkit, the desktop and the enterprise options. I find it very easy to use the desktop version. Just if you have it on my computer, or if you have out on one of the municipalities, we just start the desktop, and we can import the SIARD package, and we can look at the data. It's very easy, and of course there is room for make it even better, but already today you can just look at data and you can have a reuse. The enterprise version, of course, is more professional and can be used also even better migrating, or I don't know the exact name of it, but you can make better views and connect different tables, as Louis showed yesterday. We also have Asta 7 from Stiftelsen Asta. All over Norway, we are using the application Asta 5 for catalog system, categorization of mainly the paper archives. But as the old system are only papers, from 2008, we're starting to have systems to be fully electronic. And from years before 2008, you have combined system. You have the electronic on the screen, but you print it out to papers. But to preserve the information of those systems, we have to also preserve the database. So for many years, we have both the electronic database as the paper juridical documents on the side. So we do really can see a benefit of using also Asta 7 to have both ways in the same system. Currently, we have only a few requests for access to electronics systems, but we expect it soon to increase. So that's one of the main reasons we are looking for a visualization system to have it more streamlined. Today, the handling of those systems, if we're not using the desktop or the enterprise, we just migrate the SIARD extraction into a database. It's a MySQL or PostgreSQL, and I use a tool like dbware to just do a full either a SQL query to target what we know to look for, or we do a full text search. We can find anything. So dbware is a very good tool.
You're a bit over time. That's just a short signal, please.
Okay. Yes. Okay. This is in fact my first computer. It was a very hard choice, 8088 or 8086, but I had not so much money at the time, being a Port student, so it was 8088. Now, what's the challenges? Time is on our side. No, it is not really on our side. Finding, prioritizing, and extracting delivered to archives, can be quite the problem. User employees have left or do not recall even 2-3 years back, or certainly not longer. Describe the system, use a technical document. Front-end logic is lost or hard to do reverse engineering on, and access fails over time. We have even a system with administrator password missing. And in fact, we have a standard password. We found a friend, an old engineer that had some standard password, and sometimes we can solve it this way. Challenges: small system slices Oracle into 2 kilobyte bits. If you extract it to bin files, then we have like 50 bin sections that should be one file. We have an ad hoc solution. We program in C# and make it into one bin file and can use it in the SIARD. Some system unencrypted documents. Ad hoc solution is to make a decrypt documents section, and most of the time we have a table with the password in the database. Some old systems have binary files stored in the club text. If you do a migration and extract of the club text, it forces it to be UTF-8, and you ruin the original binary system data. So you have to make a transform from like MS-SQL and text into var binary using a middle step. You cannot do it direct. So do an SQL script in a copy of the database. SIARD suite is a good progress and good quality, and we have proven long stabilities. Sometimes problem to connect to databases, MS-SQL and Oracle. It's my experience, but it's a good tool, latest version. Same goes for the database visualization toolkit. Very good progress in the latest GUI for the web use there. Good quality. I have one Git tip issue on the lobs that is about interoperability and the spec. Sometimes problems connect to MS-SQL. The latest version developed 209 and desktop and enterprise. The validation is an excellent solution, and we have just started testing that one. We need to tune it for interoperability so we can approve all tools and all sites to spec. We are going to build a custom version and testing. So and we are going to report as well, and hopefully this lines up to even get a better tool and wider spec. The viewer, also very good way. We have a couple of questions about the easy way to implement views and reuse of the element of descriptions. We are looking at possibly using of that into DBPTK2. The Spectral Core is a very easy to use Windows high quality migration tool. Very good in extraction and a very high success rate in connect and extract. And for the end user, this is very important. We just use it, it works, and we have the extraction ready to deliver to us as archives. But we are we have 3 tools, and it's the same for us as an archive, which tool is used. If you just use a tool and it works, that is the main issue for us. So the end user are free to use whatever of those tools they want, and they successfully. We have some interoperability issues. I've just said that there is some double log-fold elements and not accept empty schemas. But as they say, this is their interpretation of the spec. So it's mostly about interoperability. And also full convert have some.
You are 5 minutes over time now. In fact, okay. Are you okay if you just finish your slides and that we don't have a discussion? Because I think you're going to finish in the next minute. So I just want to advert you. Sorry.
It's okay. I'm finished now, and I have this is some issues I have filed both on Dils's board and on the Keeps side. Earlier I had some on the SIARD suite as well, but those are fixed. And feel free to contact you on any subject if you can debate and exchange of experiences. I'm always open for this on the SIARD tools, extraction, validation, and production line or community activities.
Minimize this out, and now I will start. I will do my best to be short. Dear colleagues and everybody who's watching or listening to this workshop, my name is Martin Rechtorik. I work at the National Archives of the Czech Republic as an archivist, and my task there is surprisingly database preservation. It's a pleasure for me to take part in such a prestigious workshop, and thanks for inviting me. My presentation has 3 parts. The first part is only theory, and please forgive me. Then I want to share a practical experience with database preservation. And in the last part, I'm going to show you a possibility how we want to present data to our readers and our producers too. What does it mean to preserve a database? Have you thought about it? I think that most of us here have preserved 1, 2, many dozens, maybe hundreds. But despite having such great tools like DBPTK, SIARD, full convert, there are few relevant questions which need to be answered, which need to be considered. Which database should we preserve? Because we don't need to preserve them all. I think that Kuldar has touched this issue yesterday. How to preserve a database? Because we have more options how to do that. When to preserve a database? Sometimes data from the DB must be preserved periodically during the database lifetime. This was Louis' issue from yesterday's session. And how to present data from a database or a database itself, because we need to know which data is open data and which will probably produce a need in the future. We live in the modern era full of open data, and there won't be any time to hide or to present data. We must show them immediately. And what do we need to preserve a database? Usually, database has some type of output. Is this output suitable for preservation? Is this output suitable for presentation or not? Do we need SIPs like from record management systems from all of these databases or not? Do we need only views? Do we need statistical data or analytical data? That's the question. I think that the crucial question of our task is what information in DB has a real value and importance. Then we need to decide in the time of preservation how the data will be presented in the future. I think that presentation of preserved data is more important than it might look now. Do we need a tool for data presentation, or can we present a whole CR file if we preserve CR file? Because there can be restricted data and open data in one file. We must select a tool for preservation, because as we have heard from Torbjørn, SIARDs are not fully compatible when handling in other tools. And when you want to preserve database in a mass scale, we need to define types of database, because there are many types of databases used in the public sector. We need to define appropriate outputs. And then we must try procedures of preservation. And the last step is to share this knowledge, to train our colleagues, to train people how to do that. And it's a great news for me, at least, that under supervision of Delsi's board was established a relational database archiving interest group, because we are going to share the problem at the European level, because European Commission wants the member states to establish the databases information system which has similar outputs, which are sent to the European Commission. So we will have definitely same problem. And now it's an end of my theory, and I will start with our database preservation example. ARIS was an automatic budget information system. It contains accounting and financial data of all state institutions. It consists of 3 modules: ARIS, which contains the financial data, financial reports, financial summaries, and so on. Then the second module is called RARIS. It's a valuable and quite an interesting registry. And the last part is ARIS Web, which is interface for open data presentation. What was interesting about this system, it was from its creation intended as paperless. There are no analog records at the ministry, although some can still be found at some regional or district departments, but not everywhere, because majority was already destroyed and only very small numbers were preserved by the regional archives. Although ARIS is mainly open data, thanks preserving it in CR file 2, we are able now to present data even a full version. We wanted to emulate the whole system because of the ARIS Web part. ARIS Web had daily visitors searching and scaling the data. So our first plan was to substitute ministry, but this emulation plan turns to be too optimistic. Our limited budget would turn it in an ineffective human-operated database. And that is the reason why we select the DBDP tool, the Slovenian tool, for this data presentation. Whole ARIS and ARIS Web are still property of Ministry of Finances, but we migrated the data into Postgres, and we want to present data in our digital reading room, which is not established yet. This is how the main website of ARIS Web look like. There you have some basic information about system. There is a registry called RARIS, and there you can search for financial reports. And this is how the financial report look like. This is financial report from our presidential office for year 2001. As I have mentioned, the data from ARIS is going to be presented using the DBDP tool. And for the presentation, we use CSV exports, which are divided into 7 browsing packages. Together, it may 1,500 CSV files. And partly we use SIARD, which was exported using table filter module. And it is independent package too. These financial packages were enhanced with several simple tables to understand the meaning of the data. And the strong side of our solution is that we can deploy independently each package as open or even as restricted data. The weakness maybe is that only RARES can be required to find the necessary ID number, but it may be not a weakness because these IDs are quite well known. And if a reader wants to get a report from exact institution, then there is a high chance he already knows this ID. And this is how look like our digital reading room for databases. This is the main site, and when you select the desired database, you get there, and there you have there you can see the main selection of searches which are available for readers, and there is short overview what you can find in the database. And this is first of possible outputs from the DBDP tool. This is kindergarten. I went to as a small kid. Photo of this building is not part of preserved data, sadly, but DBDP can handle blobs or external objects quite smoothly. And it's followed by the output from the website of Archives Web. This is the same kindergarten, same data, and there is only possibility to get to the financial reports which are available for this institution. And this is how look like the financial report for this kindergarten. And there is small button, if you can see it, this is chance to download a CSV file, because this report again is followed by the original financial report, and in the Archives Web you have chance to download the Excel file. So it's quite similar. We have also preserved some other databases, but usually in CSV format or MDDB, ACCDB. But now we want to test preservation and presentation of database in a series of snapshots. We are interested in if we can use same browsing metadata for a 10 years younger snapshot of database. And we will see quite soon. My last slide, I promised you I will quick, returns attention to the opening ones, because there are issues which need to be discussed and even considered. I fear that only preservation won't be enough soon, or even right now. We live in the era of data-driven economy, and above all, we are going to be holders of knowledge how to preserve and even present data from database. Or do you think that after 20 years will be only simple description of columns of database sufficient? I don't think so. Do you think that producers like ministries will be satisfied with SIARD file, although they will request simple report, simple financial report? I don't think so. And this is just one simple example, but it might be a real one. So thank you for your attention. I'm done.
Full screen.
Now it works.
I lost my picture. Just a moment.
The introductory question, are you an IT specialist or are you an archivist?
Well, I'm more IT specialist.
Okay.
I don't see my, now I see it. I have problems with the buttons. So I created the first ingest with DBDPU 12 years ago, and it has been developed since then. And we have agreed with Martin that I present the tool. So we will concentrate on databases, on the representation information of the databases. When we store the data, we will store the original data from database, like in a SIARD object, and we will store some documentation, but we will not discuss the documentation at this point of time. We will discuss the viewer possibility for this database. How will the process run? Here we see the SIP is received by the archives. And now we want to cover 3 risks. I will come back to them later. The SIP will be immediately transformed to the DIP. This will be a test DIP. Empty DBDPU configuration will be used. And then we will simply add queries, add viewer criteria, viewer configuration. And when this viewer is finalized, the archivist will be able to study, to examine the data. And when the archivist will understand the data, he or she can reject the SIP and request another version or confirm the SIP. At this point of time, we can store the data, the content data as AIP, and in the future, when the visitor will come, we can use this information. So what are the 3 risks we want to cover? First is that we want to be sure that the content is okay before we confirm it. We want to be sure that the viewer is available, because when the database in the archives, the next day a visitor can come and request access to this data tomorrow or after 10 years. And after 10 years, we will not have time to study the documentation, the PDF, and examine the data. So what we want to have is have all this prepared right now. And the content is also studied at this point of time. Complete understanding of the information in the SIP is now completed. How do we build this representation information? I will skip some details about specific metadata. We simply build this package, and we have 2 packages. One, for example, will be a SIARD package, and another will be a viewer package. Let's jump to the reading room. Now the customer, the end user, will come and request the access to the data. We can deploy this database with a series of commands in the menu, or we use automated deployment with the order XML file, and I will show this file because it explains quite a lot. Here we have a SIARD file and a viewer file. They are already waiting on a dedicated folder, and on the right top folder we can see the command that will install the database with a single click. Database and the viewer, and immediately end user can come and use this data. Another example, only a DDView file, but here we have E as extended DDV file. What does this mean? There is not only a viewer here, we can also have comma separated values files. We can also have computer files as attachments. Actually, this was the first version of DB-Deep View where SIARD was not available yet, and it was added later. Another possibility, SIARD file and extended viewer. What would be a scenario? Maybe I use SIARD to install empty database, and all the tables are here in CSV files in the DB-Deep View package together with the viewer configuration. Another example, you can install more SIARD files and more package files, for example, for each year, or a separate package, or parts of database are installed separately. Here we also see a viewer package. This will be the last version of the viewer. Originally, the last viewer will be used from 99, but we can always make a new version of the viewer, and only the latest one will be used. So our end user is now in the reading room, and we have here three possibilities to use the database. First is a drop-down. Martin already showed one. Here you select your database. Another possibility is with a link to the database with instructions, because we can have more databases on one server, and one database can be installed more times, and so on. So Louis would say an enterprise solution. Another possibility is where the database is not public, you will not see it, so you need a special access code to come to this next screen. And here we see all the available reports. So remember, when we got first version of SIP, we created empty package, and then we configured the reports. And the last version of these reports, which are configured in an XML files, is now seen here on this screen. I select one report, I jump to the search screen, then I look at the results pane. For example, I was searching for a person, and here I select the person. This is ID 247, and I want to see the details. I go into details and see all information about this person in table view or in list view. So all this is configured, I would say hard-coded in the XML file. What is very important is in the subtitle area, we can add longer text, which will improve usability of this data. So when the user will look at the results, there will be some explanation already available. Then we can have attachments shown as content of the file. We can show the content of the blob. And as a last slide, the short wrap-up of the strategy. So no full text search, no data mining or artificial intelligence. We just wanted to imitate the original reports from the original application, and the archivists like this approach because they can see the original application, they can see our archival interpretation of the data, and they can confirm, yes, this is what we want to show to the end user when the end user comes to see the data. So this is my last slide. I apologize, I had to be quite quick.
I wanted to wrap it all up, but we're lacking time. We need a break, so I'll just skip this manual on how to do database archiving. You can look at it later, I guess. The only thing I want to show now is the but. We've seen very many ways of doing it, and there are plenty of obstacles, and that should be something, at least for the strategies group. We will enter at 11 o'clock. Understaffed DB admins, that's an issue for archives, especially when there is no commercial interest behind our actions. Too little standards, too little software support, copyright and data protection legislation, we'll talk about that as well. Proprietary extensions, that's rather something for the standards and software group. Unusual size, that's something I encountered in our work. Normal PCs don't handle any XML that is larger than 200 megabytes. I have known from Raja, I think, that, or from Boris, no, from Damir, right? Yeah, you told us that larger XML can be treated if you've got kind of a system scaled up with, say, 24 computing cores. And also the same applies to CSV at another scale. And there are obstacles like floodings, fires, earthquakes, and maybe even wars on a path of 60 years. But anyway, we'll now enter the discussion rooms.